Problem 18. Hexadecimal base 16 numbers are written using numeric digits 0 through 9, as well as the letters A through F to represent 10 through 15. Among the first 1,000 positive integers, there are n whose hexadecimal representation contains only numeric digits. What is the sum of the digits of n? So the first thing to do, like I don't see, like when I was first doing this, I didn't see really how to start. So the first thing to do is let's get goal 1. Let's get 1,000 into hexadecimal. I don't see many people do, and like the way I usually do this, it's not necessarily more efficient here in like the hexadecimal case, but it definitely makes it very efficient in binary. Actually, I'll just write 1,000 in binary first. 1,000 in, because I just think the way that you get 1,000 into binary is pretty cool. Yeah, so usually the way you get numbers into binary is like you find the largest power of 2, which we'll get into it. But you can also say that like 1,000's binary representation is representation of 500 and then 0. Or like here's a representation of 125. And then, so we have 125. That should be 250. This should be 125. And then now we add a 1. And then if this is 62, then it'll be 62 times 2 plus 1. So this should be 0, and we should have a 31. And then 31 is just going to be 5 ones. Yeah. And then, so now we convert this into hexadecimal. So this is going to be equal to 3. How many factors of, so we want to put into base 16. How many factors of 256 go into it? It's 3. Okay. So then do long division. So 232. And then how many factors of 16 go into 232? Moment of truth. Yeah, 4. Okay. Yeah, so it should be 14. I don't know what I did with the binary, but that was irrelevant anyways. Okay. So yeah. We have that 1,000 equals 3, 14, 8 in base 16. And so now this makes it a lot easier to find how many integers have a hexadecimal representation which contains only numeric digits. Like if the first digit is 0, if we have 0 something something, this gives us 10 times 10 minus 1 choices, because we can choose a numeric here, a numeric here, and then we subtract the case where it's 0. And then if the leading digit is 1, then we can choose 2 numerics. If the leading digit is 2, we can choose 2 numerics. And if the leading digit is 3, we can choose 2 numerics, and we'll all still be under like 3, 14, 8. And then so taking the sum of this is 400 minus 1, which equals 399, which gives us 21. The main idea here was to get 1,000 into hexadecimal. And then based on that, you can you do casework on the leading digit. once you set the leading digit, you can choose for every other digit behind it, you choose a numerical value, like a base 10 value, because that's the condition. Yeah, the hexadecimal representation containing only numeric digits. For each of, there's 4 different choices, 0, 1, 2, 3. We don't have to do any casework because 14 is like above 10. So like we don't have any issues where like 3, not, if it was like, if instead this was like a 9, we would have, or if instead it was like a 7, we would have to include like, we would have to exclude, manually exclude like 3, 9, 5 or something, which would be very, but it's a 14, which is nice. So that gives us 399, 3 plus 9 plus 9 equals 21.